Hello and welcome to this new additional and bonus lecture on data analytics for complexity reduction in this course on mastering complexity. So, purpose of this section is to help you learn more ways and strategies for mastering complexity. And in this particular lecture, we'll talk about how can you analyze data to identify areas of unnecessary complexity, optimize processes, and make informed decisions accordingly. So, how do you think? How to analyze data to identify areas of unnecessary complexity? See, analyzing data to identify such unnecessary complexity and making informed decisions and optimizing processes involves a combination of things like data gathering, analysis, and interpretation. Now, how can you do that? Take a look at the step-by-step guide to help you do that uh, in the process. So first thing you need to do is to define clear objective, right? So clearly define the objective of your analysis. Identify specific areas where complexity is a concern, such as supply chain, operations, or decision-making process. So define what is the pain point. Where do you think you have high amount of complexity, right? And define clearly the objectives of your analysis there. Then what you need to do is to gather relevant data from various sources. Now these sources may be internal databases, spreadsheets, customer feedback, employee surveys, or any other data repositories. Now while gathering this data, make sure the data is accurate, up to date, and covers the relevant time period. Very important because that will determine the value of your analysis and hence the result. Then what you need to do is identify key performance indicator. Define KPIs that align with your objectives. It could be metrics related to efficiency, costs, customer satisfaction, employee productivity, and any other relevant factor. Having done that, you need to clean and pre-process data. Clean the data to remove errors, inconsistencies, and outliers. Pre-process the data by organizing into a format suitable for analysis, and that may involve transforming variables, handling missing values, or normalizing data. The next step would be to do a descriptive analysis. So conduct descriptive analysis to get an overview of the data. This may mean calculating mean, median, standard deviation, or other summary statistics. Visualize data by using charts and graphs to identify trends, patterns, or irregularities. Then you need to identify areas of complexity. We're now coming to the core of this thing. Look for patterns that indicate areas of unnecessary complexity. This could involve analyzing process flows, organizational structures, or communication channel. Then identify bottlenecks, redundancies, or areas where the tasks are unnecessarily complicated, right? Then what you need to do is to root cause analysis. You've identified that from the data, what are the areas, the pain points where the complexity is high. Then you need to perform the root cause analysis. And how do you do that? So you can do interviews, you can do surveys and additional data collection, and that can help you understand the underlying reasons for complexity. Then you need to identify whether complexity is a result of outdated processes, lack of communication, or other factors. And from there, you can pick up the root cause of the unnecessary complexity. Then benchmark your processes against the industry standards or best practices. Compare your performance metrics to those to your similar organizations to identify areas where improvements can be made. Do the process mapping, create process maps or flowcharts to visualize complex workflows. This will help in identifying that steps that can be simplified, removed, or automated. And you can use the tools like swim lane diagram that we show you here to show different departments or teams contributing to a process. Then a quantitative analysis may also be needed. So conduct quantitative analysis to measure the impact of complexity on key matrices, the KPIs that you've set. For example, assess how complexity affects costs, delivery times, or customer satisfaction. Use statistical techniques to identify correlations or causation between the variables. So that's the kind of quantitative analysis you can do. Then you need to look at developing optimization strategy. To develop optimization strategy based on your finding, this could involve streamlining processes, implementing new technologies, or structuring organizational workflows. Now, out of these, prioritize areas that will have the most significant impact on reducing complexity and improving efficiency or effectiveness. Perform a cost benefit analysis to assess the feasibility of implementing optimization strategies. Consider both short term and long term costs and benefits, and perform a potential risk and evaluate potential risk and mitigation strategies. Simulation and modeling is another very useful thing. So use simulation or modeling techniques to test the impact of proposed changes before implementation. Now, what can this help? This can help you anticipate potential changes, challenges, and refine your optimization strategies. Data visualization is a need in the final stages. You present your data findings through clear and concise visualization. Use dashboards, charts, and graphs to communicate complex information in an understandable format. Create visual representations of before and after scenarios to illustrate the impact of your optimization strategy. Then finally communicate your findings and recommendation to the stakeholders, right? Clearly articulate the benefits of the optimization and how it aligns with the organizational goals. Gather feedback and address concerns to ensure buy-in from the relevant parties. Finally, coming on to implementation and monitoring. Implement the approved optimization strategies and monitor the impact over a period of time. Continuously gather feedback and adjust strategies as needed to ensure ongoing improvement. So establish finally continuous improvement is not to be forgotten. Establish a culture of continuous improvement. Encourage teams to regularly assess process, gather data and identify opportunity for further optimization, and implement feedback loops to incorporate lessons learned from the previous optimization effort. So you will need to use some tools for data analysis. So what are such tools that you can use? In spreadsheet software, Excel and Google Sheet are wonderful to stick to. Data visualization tools, you can use Tableau and Power BI. Statistical analysis tool, R and Python with libraries like Panda and NumPy are very useful. And in process mapping tools, you can use Lucidchart and Visio. So having looked at all this, if we follow this structured approach, you will systematically analyze data, identify areas of unnecessary complexity, and find and implement effective strategy for process optimization and decision making. Continuously monitoring and a commitment to ongoing improvements are crucial elements for successfully managing complexity in business. So thank you so much for watching this additional and bonus lecture on data analytics for complexity reduction. In this course on mastering complexity, I hope you're continuing to learn new things, continuing to enjoy. Please feel free to message me if you have any question that you'd like me to answer for you. And also please do download the PDF file to take a look at anything that we have talked about in this lecture.